Hey everyone, welcome back. Ready to explore a world where machines can write poems and summarize complex information.
Sounds fascinating.
Today we're diving deep into large language models, or LLMs for short.
Definitely a hot topic these days.
It's a huge field, so we're going to focus on giving you a solid foundation, how they work, why they matter, and what's on the horizon for this game-changing technology. Our guide for this deep dive is the text LLM design, theory, architecture, and application.
A great resource for understanding the intricacies of LLMs.
We'll be uncovering some really cool stuff like, did you know that LLMs are built on something called a transformer architecture?
It's the secret sauce that revolutionized the field.
We'll explain what that is and why it's so important.
Yeah.
We'll also delve into how these models are trained.
Hint, it takes mountains of data and some serious computing power,
And get this, there are ethical concerns around LLMs too.
like bias and the potential for misuse. We'll definitely get into that.
But first things first, what exactly is an LLM?
In the simplest terms, it's a type of AI that's really good at understanding and generating human language.
So like a super smart chatbot.
You could think of it that way, but it's much more than that. They can do things like write stories, translate languages, answer your questions in a comprehensive way, and even summarize complex information, kind of like what we're doing right now.
Yeah, taking a dense academic text and making it digestible for our listeners. But LLMs are doing that on a massive scale. They haven't always been so advanced, though, have they? What did those early language models look like?
Um, Imagine a toddler learning to speak.
Okay, making cute but jumbled sentences.
Exactly. Early models used simple statistical methods to predict word sequences. They were pretty limited in their ability to understand context and generate complex language.
So when did they start sounding less like toddlers and more like, well, articulate speakers?
The introduction of neural networks was a big step forward. Models like RNNs and LSTMs emerged.
RNNs and LSTMs.
Recurrent neural networks and long short-term memory networks. They were much better at handling sequential data, like words in a sentence.
So they went from toddlers to teenagers who grasped grammar.
Yes. But the real turning point was the transformer architecture.
The transformer architecture, it sounds almost magical. What made it so special?
The key is this thing called the self-attention mechanism.
Self-attention.
It allows the LLM to focus on the most important words in a sentence, just like we do when we read. This helps it understand context and meaning much more effectively.
So it's like the LLM is paying attention to the key players in a sentence, figuring out who's doing what to whom.
Exactly. It's a game changer. And it doesn't stop there. The transformer can also process information simultaneously, unlike us humans who read linearly. It can consider relationships between words that are far apart, capturing those long-range dependencies.
So even though it's processing everything at once, it still knows word order matters. The cat sat on the mat isn't the same as the mat sat on the cat.
Right. And for that, it uses something called positional encoding.
Okay.
It's like giving each word a numbered cue card so the model knows the sequence.
That's really neat. But how do transformers handle tasks like, say, translation?
That's where the encoder-decoder structure comes in. The encoder processes the input language, breaking it down and understanding the meaning.
Okay, so it's like deciphering the code.
Right. And then the decoder takes that understanding and generates the output language.
So it's like a relay race. The encoder grabs the message, figures it out, and passes the baton to the decoder, who sprints to the finish line with the translated text. But building and training these LLMs sounds like a massive undertaking.
Absolutely. It's a huge endeavor. You need massive data sets, mountains of text from books, websites, articles, social media feeds, everything you can imagine.
The more data, the better, right?
Exactly. The more data the LLM is trained on, the better it can learn and understand the nuances of language.
Just how much data are we talking about here? Give us a sense of the scale.
Think billions, even trillions of words. Some models are trained on data sets like the entirety of Wikipedia, Common Crawl, and huge news archives.
Wow, that's mind-boggling. It's not just about throwing data at the problem, though, is it? There's a specific process involved in training these LLMs, right?
You got it. First, you have data ingestion, where all that raw data is collected and organized. Then comes data pre-processing cleaning, normalizing, and formatting the data so the LLM can actually understand it.
So it's like prepping all the ingredients before you start cooking?
Perfect analogy. You need to make sure the data is high quality and consistent. Any errors or inconsistencies in the data can negatively impact the LLM's performance.
It's like a recipe. If you use bad ingredients, you'll end up with a bad cake. So what happens after the data is prepped and ready to go?
Next is model initialization, setting up the LLM's architecture and initial parameters.
It's like laying the foundation for the LLM's brain.
Exactly. This phase involves deciding on the number of layers, the types of attention mechanisms, and many other parameters that affect the model's complexity and performance.
Sounds like there's a lot of expertise involved in that initial design phase. What happens once the model is initialized?
Then the real magic begins, the training loop. This is where the LLM processes batches of data, learns patterns, and adjusts its internal weights to improve its predictions.
So it's learning from its mistakes, getting better with each iteration.
Precisely. It's an iterative process, with the model constantly refining its understanding of language.
And this training process must require some serious computing power, right?
You bet. We're talking powerful computers, specialized hardware like GPUs and TPUs. Those are graphics processing units and tensor processing units designed specifically to handle these massive calculations.
Sounds intense. It's like running a marathon for a computer. And this training process doesn't happen overnight, does it?
No, it can take days, weeks, even months, depending on the size of the model and the data set. It's a computationally intensive process.
Wow, a lot of time and resources go into building these LLMs. The work isn't over once the model is trained, is it? There's more to do, right?
Right. Again, we need to optimize the LLM.
Optimize it. What does that mean and why is it so important?
Think of it like fine-tuning a race car. You want it to run faster, use less fuel, and perform at its best. That's what optimization is all about, making the LLM leaner, meaner, and more efficient.
I like the sound of that. A lean, mean language machine.
Okay.
What are some of the benefits of optimizing LLMs?
Well, for one, it saves time and money. Optimized LLMs run faster and use fewer resources, which is a win for everyone.
So it's about making the technology more sustainable.
Exactly. It's about reducing energy consumption and making the technology more accessible.
So you're not just making the LLM perform better, you're making it more democratic as well. Tell us about some of the techniques used to optimize these LLMs.
One technique is called mixed precision training.
Mixed precision. What does that mean?
It's like switching from high definition to standard definition
Right.
when you don't need all those extra pixels. You still get the picture, but it takes less processing power.
Ah, so you're using lower precision for some calculations without sacrificing accuracy. That's clever. What other techniques are there?
Another one is gradient accumulation. Imagine making fewer trips to the grocery store, but buying more each time.
Okay, well, so it's about being strategic with your resources.
Exactly. Gradient accumulation does just that. It accumulates gradients over several mini batches before updating weights, which makes the process more efficient.
Streamlining the training process, reducing the computational overhead.
Precisely. And then there's early stopping.
Early stopping. Doesn't that sound counterintuitive?
It might sound that way, but it's like knowing when to stop studying before you burn out. It prevents overfitting, which is when the model becomes too specialized to the training data and performs poorly on new, unseen data.
So it's about finding that sweet spot where the model has learned enough to be effective, but hasn't memorized the training data to the point where it can't generalize to new situations.
Exactly.
But all these techniques are really ingenious. It's amazing how much thought goes into making these LLMs as efficient as possible.
There's a lot of clever engineering involved, and we're constantly finding new ways to push the boundaries.
And we're not just limited to text anymore, right? There's this whole other world of multi-modality where LLMs can work with images, audio, and even video.
Absolutely. Multimodality is the future of LLMs.
Right.
It's about giving them the ability to understand and generate different types of data, not just text.
So they can actually see and hear. That's mind-blowing.
Wow.
What are some of the potential applications of multimodal LLMs?
Oh, the possibilities are endless. Think of LLMs that can describe an image, but also answer questions about it.
So not just captioning, but actual understanding of the content of an image.
Precisely. Or imagine video summarization, where an LLM can condense hours of footage into a concise summary.
That would be a game changer. It's like we're giving these LLMs superpowers.
And it's already happening. There are fascinating case studies of multimodal LLMs being used in healthcare diagnostics, personalized e-commerce recommendations, even energy-efficient AI in finance.
We're definitely going to have to dive into those case studies in more detail. But before we move on, I'm curious about the ethical implications of all this. LLMs are powerful tools, but with great power comes great responsibility, right?
You said it. There are definitely ethical concerns we need to address.
Like bias, for example. We've already seen how easily bias can creep into AI systems. How can we ensure that LLMs are fair and unbiased in their decision-making?
It's a crucial question. We need to be very careful about the data we use to train these models and implement strategies to mitigate bias throughout the development process.
So it's about being proactive, not just reactive. And what about the potential for misuse? LLMs could be used to generate fake news, deepfakes, and other harmful content. How do we prevent that?
That's a real concern. We need to develop robust safeguards and ethical guidelines to ensure that these powerful technologies are used responsibly.
It's a complex issue with no easy answers, but it's a conversation we need to have as we continue to push the boundaries of AI. Welcome back to our deep dive into the world of LLMs. We've covered a lot of ground, from the basics of what LLMs are to the complexities of training and optimizing them.
And we even touched upon the fascinating realm of multi-modality, where these models go beyond text and start working with images, audio, and video.
It's mind-blowing stuff. But now let's shift gears and explore how these incredible LLMs are actually being used to tackle real-world problems.
We'll be delving into some fascinating case studies from our source text, LLM design, theory, architecture, and application.
These case studies really highlight the versatility and impact of LLMs across a wide range of fields.
It's amazing to see how this technology is being applied to make a real difference.
Let's jump right in with case study 1, which focuses on healthcare diagnostics.
This particular case study centers around a large hospital network that was facing challenges in their radiology department.
Radiology, that's the department that deals with medical imaging, right? X-rays, CT scans, and all that.
Exactly. And generating reports from those medical images was a major bottleneck.
I can imagine. Translating those complex images into detailed written reports must be incredibly time-consuming for doctors.
It was a slow and error-prone manual process, which often led to delays in diagnosis and treatment.
Not ideal when you're dealing with people's health.
Absolutely. That's where the multimodal LLM came in. They implemented a system that combined a vision transformer, a type of AI that can see and interpret images, with a GPT-like model that's great at understanding and generating text.
So they essentially gave the LLM both eyes and a voice, the ability to process both the visual information from the images and the textual context of medical reports.
Precisely. It was a powerful combination.
What kind of results did they see? Did this approach actually improve things?
The results were pretty remarkable, actually. The LLM achieved a 92% accuracy rate in generating radiology reports, which led to a significant reduction in report turnaround times.
Wow, that's impressive. Faster diagnoses, quicker treatment decisions, that's a game changer for patient care. But I'm curious, how did the doctors react to having an AI essentially assisting them in the diagnostic process?
That's a great question. You're right, trust is paramount in healthcare. The key here was transparency. The developers designed the system in a way that made the LLM's attention mechanisms explainable.
Explainable. What does that mean in this context?
It means that the doctors could see which parts of the images the AI was focusing on when it made its assessments. They could understand the AI's reasoning, which helped build trust in the system.
So it's not just about the AI spitting out a diagnosis. It's about showing its work, so to speak, allowing the doctors to understand how the AI arrived at its conclusions.
Exactly. Transparency is crucial for building trust and ensuring responsible AI adoption, especially in sensitive fields like healthcare.
This case study is truly inspiring. It shows how LLMs can empower doctors, improve patient care, and ultimately save lives. Now, let's switch gears to something a little closer to home: online shopping.
Ah, the world of e-commerce, a perfect playground for LLMs.
Case study 2 delves into the realm of personalized e-commerce recommendations, those algorithms that seem to know our shopping habits better than we do.
It's amazing how they can suggest products that you didn't even know you wanted.
I know, right? Sometimes it feels like they're reading my mind.
Uh,
What was the specific challenge that this case study focused on?
it revolved around a large e-commerce platform that was struggling to personalize recommendations across a wide range of product categories.
That's a tough one. It's one thing to recommend products within a specific category, but to create a system that can cater to diverse tastes and preferences across multiple domains, from electronics to fashion to home decor, that's a whole other level of complexity.
It is. They wanted to move beyond generic recommendations and really tailor the experience to each individual user, but it was proving to be a significant challenge.
So how did they use an LLM to tackle this problem?
They took a pre-trained LLM and fine-tuned it using cross-domain adaptation techniques. Think of it as teaching the LLM to speak multiple shopping languages.
Interesting. So they're training the LLM to understand the nuances of different product categories and user preferences. It's like having a personal stylist, a tech guru, and an interior designer all rolled into one.
Precisely. And they used few-shot learning and prompt engineering to make this process even more efficient.
Can you explain those techniques a bit further?
Sure. Few-shot learning allows the model to learn from a limited number of examples, which is incredibly helpful when you're dealing with a vast and constantly evolving catalog of products. Prompt engineering, on the other hand, involves carefully crafting the inputs to the LLM to elicit the desired responses, in this case, highly personalized product recommendations.
So it's about guiding the LLM, giving it just enough information to understand the context and make the right recommendations. Did this approach yield positive results? Did they see an improvement in their recommendation system?
The results were pretty impressive. Click-through rates increased by 25%, and conversion rates, that's the percentage of people who actually make a purchase, rose by 18%.
Those are some significant improvements. It seems like the LLM was able to effectively connect with shoppers on a personal level and provide them with recommendations that were truly relevant to their interests. But I imagine scalability was a major concern, especially for a large e-commerce platform.
Oh, absolutely. They had to make sure the system could handle massive amounts of data and user traffic, especially during peak shopping seasons like Black Friday and Cyber Monday.
You can't have your recommendation engine crashing when millions of people are trying to shop. How did they address that challenge?
They implemented a hybrid deployment strategy, combining the power of cloud computing with the efficiency of edge devices.
Can you explain that a bit further? What are edge devices and how do they fit into this picture?
Edge devices are essentially devices located closer to the users, like local servers or even the user's own device. By distributing the workload across the cloud and these edge devices, they were able to create a more robust and responsive system that could handle those massive spikes in traffic.
It's like having a global network of servers working together to deliver personalized recommendations in real time. That's pretty impressive.
It is. It's a great example of how thoughtful system design and infrastructure are crucial for successfully deploying LLMs, especially at scale.
Now let's move from the world of shopping to the world of finance with case study 3. This one focuses on reducing energy costs for AI operations in a fintech company.
This case study is all about sustainability and efficiency, which are becoming increasingly important in the world of AI.
Absolutely. These powerful AI models require a lot of computing power, which translates into high energy consumption. What was the specific challenge that this fintech company was facing?
They were using LLMs extensively for critical tasks like fraud detection and credit risk assessment. These operations were essential for their business, but they were also consuming a lot of energy and generating a significant carbon footprint.
So they were faced with a dilemma how to continue leveraging the power of AI while also minimizing their environmental impact.
Exactly. They needed to find a way to make their AI operations more sustainable.
What approach did they take to address this issue?
They adopted a multi-pronged approach, combining several different strategies to reduce energy consumption. First, they implemented model compression techniques, like quantization and pruning.
Those sound like some serious technical terms. Can you break those down for us a bit?
Of course, quantization essentially involves reducing the precision of the numbers used in the model's calculations. It's like switching from using high-definition images to standard-definition images when you don't need all those extra pixels.
So you're making the model more lightweight without sacrificing too much accuracy.
Exactly. And then there's pruning, which involves removing unnecessary connections or parameters in the model's architecture. It's like trimming the fat, so to speak, making the model leaner and more efficient.
It's like giving the LLM a Marie Kondo makeover, tidying up its internal structure, and getting rid of anything that doesn't spark joy, or in this case, computational efficiency.
I love that analogy. They also implemented a technique called knowledge distillation.
Knowledge distillation. That sounds intriguing. What does that involve?
It's a process where a smaller, more efficient LLM learns from a larger, more complex LLM. It's like having a seasoned expert train a new recruit, passing on their knowledge and experience in a more concise and efficient way.
So they're essentially creating a more sustainable generation of LLMs that can benefit from the knowledge of their predecessors without inheriting their energy-hungry habits.
Exactly.
What kind of results did they achieve with this multi-pronged approach?
The results were impressive. They were able to reduce their energy usage by 40%, which translated into significant cost savings and a smaller carbon footprint.
That's fantastic. So they're not just saving money, they're also reducing their environmental impact. Were there any other benefits to this approach, aside from energy efficiency?
Yes, actually. They found that the smaller, more efficient LLMs also led to faster inference times, which means their fraud detection systems became even more responsive.
It's a win-win-win situation. They saved money, reduced their environmental impact, and even improved the performance of their AI systems. This case study really highlights the importance of considering energy efficiency in LLM design and deployment.
It's a crucial consideration, especially as we continue to develop and deploy increasingly complex and powerful AI models.
Well, we've covered three fascinating case studies so far, each showcasing the real-world impact of LLMs in different sectors. But our journey isn't over yet. We have two more case studies to explore.
In our next segment, we'll delve into case study 4, which tackles the issue of bias mitigation in recruitment chatbots.
And we'll wrap up with case study 5, which explores how explainable LLMs are being used to enhance legal research.
Stay tuned for more insights into the real-world applications of LLMs.
And we're back for the final leg of our LLM deep dive. We've explored the inner workings of these models, their evolution, and how they're being applied in various fields.
It's been quite a journey through the world of LLMs.
Absolutely. Now let's wrap up our exploration with two final case studies that highlight the real-world impact of these models.
These examples showcase how LLMs are not just theoretical concepts, but powerful tools that are transforming the way we work and solve problems.
Case study 4 takes us into the realm of recruitment, a field where fairness and impartiality are paramount. It focuses on a global HR platform that was using an AI chatbot to screen resumes. But as we've seen, even with the best intentions, AI can sometimes perpetuate existing biases.
Exactly. And that's precisely what happened in this case. The chatbot, trained on historical recruitment data, unfortunately, learned and started to reflect the biases present in that data.
Leading to unfair outcomes for certain demographic groups.
Yes, which is a serious problem, especially when you're dealing with people's livelihoods and careers. It underscores the need to be incredibly vigilant when deploying AI in sensitive areas like hiring.
So how did they address this issue? What steps did they take to ensure that their AI-powered recruitment process was fair and unbiased?
They implemented a comprehensive strategy that combined both technical solutions and human oversight.
A two-pronged approach.
Exactly. On the technical side, they employed advanced techniques like adversarial training and counterfactual data augmentation.
I've heard of those terms, but can you refresh my memory? What do they actually mean in this context?
Sure. Adversarial training is a bit like training the AI to play devil's advocate against itself. You're essentially forcing the model to confront its own biases by introducing data that challenges those biases, helping it to become more robust and fair.
So it's like teaching the AI to question its own assumptions and think more critically.
Exactly. And then there's counterfactual data augmentation, which involves creating hypothetical scenarios that explore different possibilities. For example, what if a candidate's gender or ethnicity was different? How would that affect the AI's assessment?
It's about broadening the AI's perspective, exposing it to a wider range of possibilities, and helping it to make more balanced decisions.
Precisely. And they didn't stop there. They also implemented a fairness-aware training pipeline, integrating tools like AI Fairness 360, which is designed to detect and mitigate bias throughout the development process.
So it's like building fairness checks and balances into every stage of the AI's development. It's not just about fixing problems after they arise, but preventing them in the first place.
Absolutely. But they also recognize that technology alone isn't enough. They also incorporated human oversight into the process, allowing HR professionals to review and potentially override the chatbot's decisions.
So there's still a human in the loop, which is reassuring. It prevents the AI from becoming a black box and ensures that human judgment remains a critical part of the decision-making process.
Exactly. It's about finding the right balance between AI and human intelligence, leveraging the strengths of both.
Did they see positive results from this approach? Did those efforts to mitigate bias actually make a difference?
The results were encouraging. They observed a 30% reduction in bias-related incidents, and feedback from both candidates and HR teams indicated increased trust in the platform.
That's great to hear. It's proof that it's possible to develop and deploy AI systems that are both effective and fair. Now, for our final case study, let's shift gears once again and explore the world of law with enhancing legal research with explainable LLMs. It focuses on how a legal tech firm developed an LLM to assist lawyers with the incredibly complex task of legal research.
Lawyers spend countless hours poring over legal texts, searching for relevant case laws, precedents, and statutes. It's a process that can be incredibly time-consuming and intellectually demanding.
It's like trying to find a needle in a haystack, but the haystack is made of legal documents. What was the specific challenge that the LLM was designed to address?
The key challenge wasn't just finding the information, but understanding the reasoning behind it. Lawyers need to be able to explain their legal arguments to their clients and in court. They can't simply say, "the AI told me so."
They need to be able to articulate the logic and the justification for their arguments.
Exactly. And that's where explainable LLMs come in. Instead of just providing answers, these models can also explain how they arrived at those answers, citing relevant case laws, precedents, and legal principles.
So it's like having an AI legal assistant who can not only find the information, but also explain it in a way that lawyers can understand and trust.
Precisely. It empowers lawyers to make more informed decisions and build stronger cases.
Did this approach prove to be effective? Did lawyers find this tool to be helpful in their work?
The results were quite impressive. Lawyers reported a 40% reduction in research time, which freed them up to focus on more strategic tasks. And importantly, the explainability of the LLM led to wider adoption within the firm.
Makes sense. Lawyers are more likely to use a tool if they understand how it works and trust its recommendations.
Exactly.
Well, there you have it, folks. We've journeyed through 5 fascinating case studies, each showcasing the real-world impact of LLMs in various fields.
We've seen how these models are being used to improve healthcare, personalize online shopping experiences, make financial operations more sustainable, promote fairness in hiring, and even enhance legal research.
It's clear that LLMs are not just a passing fad. They're a transformative technology with the potential to revolutionize countless industries and aspects of our lives. But as we've discussed, it's crucial to develop and deploy these models responsibly and ethically, addressing issues like bias, transparency, and accountability.
Absolutely. The future of LLMs is bright, but it's up to us to ensure that these powerful tools are used for good to benefit all of humanity.
Well said. Thank you for joining us on this deep dive into the world of LLMs. We hope you found it informative and insightful. Keep exploring, stay curious, and who knows what amazing advancements await us in the years to come. Until next time.